Okay, guys, welcome to Battery Design, Testing, and Service. This is the lecture for batteries that I'm going to give you. I want you to be able to diagnose and test batteries. This will help you in that process. It's not going to make you perfect battery diagnostician, I guess, if you want to say, but it will help you to get an understanding and foundation of the fundamentals of the battery. So I'm going to get things switched over here and get going. I'll probably be off. I'm going to enlarge the PowerPoint to full screen so that you guys can see the PowerPoint as I talk. I may pop in and out. I'm going to be just sitting here like this the whole time. So uh, obviously we have 40 slides to get through, a lot of information to cover. So we're going to cover as much as we can, as fast as we can. Okay. So here we go. All right. Now we're here. Let me get this set up. All right. Off we go. Battery testing designs. So in the battery, there's a lot of different things that we need to be aware of that's going on. And there's a lot happening in a battery that a lot of people don't realize. If you look at this, you have negative plates, negative lead plates. You have positive lead plates. Each cell encompassing from this point to this point being a cell, this point to the edge of the case being a cell. There's 6 cells to a 12-volt battery. And in that 12-volt battery, we're going to have 6 cells at 2.1 volts per cell. That's a total of 12.6 volts for the battery. So the open cranking voltage, and if I can give you a hint on this, OCV. So OCV, we want to take a note of this. OCV equals, for the automotive world, in most cases, 12.6 volts, okay? So you want to be at OCV of 12.6. Here you can see that the different parts of the battery. There's the vent caps. Not all batteries have vent caps. We're going to talk about the different styles of batteries. There's AGM, there's SLA. We talk about the different styles and how they are affected and how they use those batteries. You're going to have the negative terminal, the positive terminal. Of course, I highlighted those backwards as I said them. But and then the electrolyte solution, in this case, if it's a SLA battery or a lead acid battery, it's going to have an electrolyte solution. There's this myth out there that you can just put distilled water in it and top off the battery and bring it back up to the normal level of solution. That is a false myth. That electrolyte is balanced to a very specific gravity ratio. And if you misbalance that by changing it and adding just distilled water, sure, if you're going to add water to it, distilled water is the thing to add to it, because you don't want to add minerals and things in there that should not be in there. But that battery has a very specific gravity that needs to be in there, and that's obtained by putting battery acid in the battery like it's supposed to have. Okay, and when you come to lab, I'll show you a case of battery acid, show you how you can rebuild some of these batteries sometimes. But really, when a battery goes dead, a battery's dead. Hopefully this lecture will help you see some of those things. Okay, so these are some of the objectives that we need to discuss, and some of the things that are going to be happening. We're going to discuss the battery types and the designs, the most common of the industry and what we use. We're going to list out some of the precautions necessary to use when working around batteries. By this point in time, hopefully at this point in time, you have already recognized some of those and you already know some of those safety precautions. It's very important to understand all of those safety precautions, guys. The hazard to you is so great in the event that you blow up a battery. So this is not something that you take lightly when you're messing with batteries. There's chemical burns that can take place. There's explosions that can take place. A combination of both physical burns, heat burns, chemical burns, skin getting burnt off and melted through with acid, all the other things that could happen underneath once your skin's been penetrated. So there's so many physical debilitating things that could happen to you that you need to be very safe when working around the batteries and understand what you're working with. Okay, so then we're going to describe the impact of keeping a battery clean and how and why we keep it clean, how that affects the vehicle, how that affects the starting system, the charging system. It all has a major effect on the whole electrical system of the car, and it's important and critical to ensure that we keep things clean. Okay, discuss how to test the batteries for open circuit voltage and specific gravity. I'll show you a quick test down and dirty, and then when you come to lab, that's one of your labs you get to deal with and do that and work with that. Okay, and then we're going to describe how to perform a battery load test. Load testing today is kind of a old school method, if I might say that way, with great caution, but there's still a valid purpose for a load test. However, when you get a certain type of battery, load testing is bad, and under certain conditions, load testing is bad. But the key thing to know about a load test is if it can handle the load, and it can handle the load, is that battery got sufficient capability to start a car? Probably. However, does that battery have sufficient ability to reclaim what it lost very quickly and to revive itself to a 12.6 healthy state, or at least a 12.4, which is 75% state? And we'll talk about what state of health is and things like that. Describe how to perform a battery load test and the conductance test. The other component to that load test comes down to a conductance test. We'll talk a little bit about what conductance test is, how it works. It works under micro loads, not under what's the word I'm looking for? Not under a heavy saturation load. Okay. All right. So load testing is a massive saturation of the battery and a massive load on it. Conductance test is a light load, looking at recovery rates and the ability for the battery to recover and replenish itself. Okay. All right, moving on. So car battery basics. The automobile battery hasn't outwardly changed much, guys, over the years. The lead acid battery is the most common. The SLA battery is the most common. There's been some design changes for some cars, like I know, for example, my BMW 3 Series. That car, the battery in it is what's called an AGM battery, because I can't have gaseous fumes coming off of the battery. And there's a reason the AGM battery can accommodate that situation. We'll talk about that when we get to talking about what AGM batteries are. So take a note about that. But that battery sits in the compartment with the passenger, and that's not good to be able to have that hydrogen release in the car that comes off of a battery that we're going to talk about. All the way back when I worked for BMW, all the way back to, I would say, 2000 and gosh, gonna go back to 2000, back to 1995 even. BMW was putting the batteries behind or underneath the rear seat of the vehicle, and so that was in the cabin of the car. Okay, so heavy usage also cuts battery life short. We'll talk about the application of heavy usage and things like that and what that can do to the battery. Hopefully you'll recognize that when we're done. All right, so let's talk about the starting, lighting, and ignition battery, lead acid batteries here. And let me cut this down for a little bit here. It looks like it's not entirely on the screen, and I hope I didn't in the last slides cut them short for you, but if I did, I'm going to leave it alone. So I don't want to go back and reshoot the whole video, if that makes sense at this point in time. So let's quickly adjust this for you so you can see the whole slide. Okay. All right. So the vast majority of automobile batteries are starting, lighting, and ignition SLI batteries. That means that they literally are there for the purpose of starting the vehicle, providing capability for the lights on the interior of the vehicle when you open the door, things like that. Okay. And providing power or energy for the ignition system on the vehicle. They are not designed to be saturated hard. They are not designed to be pulled down hard. They are not designed to run big, loud stereo systems on a consistent basis. They're designed solely to be put into the vehicle to run the everyday ins and outs of that vehicle, and not for long, extended amounts of time. The other thing about an SLI battery is they have what's called a shallow charge cycle. The time it takes to run the battery down and charge it back up. And that shallow charge cycle is important and key in a use of a vehicle, because you think about it, what we do is we pull 165 to 150 to 200, 225 amps off of that battery, really fast to start the engine. But then that alternator kicks in and immediately starts to push all that amperage back into the battery over a 3 or 4 minute period. And so that battery is quickly releasing and dumping a ton of electrons and turning a starter over, and then quickly absorbing a ton of electrons coming um, from the alternator. So there's a lot happening really fast as that battery switched around, and a lot of heat is taking place as electron transfer happens, right? So hopefully at this point by now you understand that when electrons pass certain points, we have a transfer of heat that takes place, and heat is created. Tesla just recently announced on September 26, 2020, that they came up with a new battery, and the premise behind that battery is that the electrons do not have to travel as far to get from one place to the other inside of the battery by the way they built that battery. Therefore, they can keep the batteries cool, they can keep the batteries from getting overheated, and they can rapidly charge the batteries in 10 to 15 minutes and cycle the batteries down very quickly and not overheat the batteries. This is in an effort to get to that $1,000,000 or $1,000,000 battery that can go for 1,000,000 miles before it has to be replaced. The other component to that with that battery design that they've created is it's fully recyclable. Everything can be recycled, can be refurbished and reused again and made into another 1,000,000 mile battery. So they're really making some major leaps in advancements. Kind of stinks for GM and General Motors and all these other manufacturers that thought they were finally catching up to Tesla. And then Tesla comes out and says, "Ha, you guys thought you caught us, but look what we just did." And so Tesla is hands down got the technology that's miles ahead of everybody else when it comes to the batteries. Okay, so moving on to our next slide here. The effects of long stand time and lack of use. I'm going to talk about a couple of things here. The inside of the battery and the electrolyte is generally comprised of 35% sulfuric acid and 65% water. That's the solution in an SLI battery, okay? And the SLI batteries with that kind of solution, believe it or not, is pretty toxic. That acid is still pretty toxic. The best way, an absolute best way to ever shut down any kind of sulfuric acid like this is baking soda and water. Just grab some baking soda, mix it up with water, and pour it on the carpet, or if it's battery acid, wherever it is, spread it out. It will neutralize that acid and shut the acidic effect down and stop whatever it's destroying. I don't know, and I can't speak to that from a health perspective and say whether or not that's the best thing from a health perspective to do, but it's there something to think about and something to keep in mind. Okay, that the battery could potentially leak acid, and the best way to clean that is baking soda and water. Best neutralizer I've ever seen. Okay. So when a lead acid battery is inactive, though, one of the things that we have to worry about is the discharge rate. The acid is heavier than the water in most cases because it's minerals, right? And what happens is the acid starts to settle towards the bottom of the battery. So you hear this story about people saying, well, if I set a battery on the concrete, I'm going to have this horrible battery that is going to die because concrete sucks the energy out of the battery. That's false. What's not false is that the concrete of the concrete floor that you set that battery on constantly and is in most cases going up and down in temperature. So as the temperature rises up and then the temperature drops, and this is sometimes multiple times in one day, that the temperature in the concrete floor will go up and down. And if you're in a shop where they have heated floors and they're running heaters, then it's really changing, right? So what happens is as you run that and go back and forth through all of these temperature fluctuations, the battery up here tends to get the acid level down inside of it, and the acid starts to settle down in around the plates and starts to short the cells in the battery. And I start to get the mineral concentration in one place down in the bottom of the battery, right? And rather than it being suspended in a normal battery like this, and I see all the minerals, they all start to compress and come into this application here. And the battery then starts to get shorted cells because all the minerals are sinking to the bottom, shorting the cells of the battery. inside the case of the battery, if it's a SLI battery, there's supposed to be some chambers at the bottom that allow for that sediment to settle down as the plates degrade and as the plates shed off the excessive coatings on the outside of the plates. That mineral content that sheds is supposed to build up in these little compartments down here and not affect the shorting out of the plates. But as you let it sit and as that battery is exposed to the up and down temperature variation of the concrete, then the minerals start to settle and it then starts to bring the battery down to its knees. And that's bad. That's where the concrete, and that's why setting a battery on concrete is bad. Not because the concrete sucks the minerals down or not because the concrete makes the battery go dead. The concrete makes the battery go dead because of the temperature fluctuations in the concrete. Concrete is constantly under a temperature fluctuation. In a single day, it may change 4, 5, 6, 7, 8 times in temperature, causing the battery to do the same and causing effects there. Okay, so the effects of long stand time and the lack of use on a battery is ultimately in the end going to damage the battery. This condition is referred to as acid stratification. Okay, and since it's the concentration of the sulfuric acid that lowers the electrolyte level freeze points, the upper level of the acid tends to not freeze, but the lower level structures, the acid, will start to begin to freeze. And that will give you a frozen battery. You can't charge a frozen battery. If you try to charge a frozen battery, you take a chance of damaging it, one, or blowing it up, two. And it's a very bad thing. So if you're dealing with a frozen battery, you should take that frozen battery and put it in a room somewhere that can defrost it in the range of at least 50, 60 degrees until that battery comes to temperature. And you need to leave it there for probably a good 6 to 12 hours and let that battery completely come to temperature, and then try to charge it or do what you want to do to it to service it and recover it. Not going to deal with that much here in California, at least in the Central Valley of California, down here in the lower levels in the LA market and San Francisco and those places. But you get up in the mountains, you're absolutely going to deal with that. You get up into Utah and other countries out in Nevada and places where there is snow and ice, it's a legitimate concern for about 6 to 8 months of the year. I know when I lived in Montana, it was definitely a concern for at least 8 months a year, where we dealt with batteries that were being froze on a consistent basis. Okay, so we got to be careful with that. You got to pay attention to it. Temperature does matter on what these batteries are dealing with. Okay, all right, so then there's the AGM battery. This is kind of the onset, and the most common one that everybody's used to is the Optima round cell AGM battery. Most Europeans and some domestic luxury vehicles are equipped with a 12-volt absorbent glass mat battery. And I want to emphasize that, the absorbent glass mat. AGM stands for absorbent glass mat. Make sure that you pay attention to that and make sure you understand that. Let's go ahead, and before we get too far into the AGM battery, let's take a little break, and then we'll come back. All right, so we're back from break. So we now know what an absorbent glass mat battery is, or abbreviation to absorbent glass mat is, which is AGM, right? So the battery is similar to the current vehicle's lead acid, flooded acids, except it uses glass mat to absorb the electrolytes. And what that means is that right here, if we look at this, let me get my highlighter up. Inside here, you see like the spirals. It's a matting, and you can see here the different grid type effect of the lead here for the battery, and then they wrap it with a fiberglass mat. This fiberglass mat wraps around it or is set side by side to it in a square battery like you see here. Right here, it's plates that are set side by side, but they are little pockets inside the little plates or inside the little matting that hold the acid. And the same thing goes for these spirals. And so the nice thing about those AGM batteries, they can be turned sideways, they can be turned upside down, they can be laid on their back, they can be laid on their fronts, they can be laid in any direction. They don't have a gas off that's as bad as the SLA by any means. Most of the time that gas off can be vented through a little tube if it does gas off. You still have to be careful with them when jump starting them. You still have to follow the jump starting procedures that you learned in Introduction to Auto so that you understand that they can too blow up. They are still a battery. They still have acid. They still have the same electron movement capability, EMF capability that any other SLI battery or the SLI batteries have. So, or the SLAs, or I always say SLA and I don't know why, but it's SLI. So this allows for a smaller, lighter battery though, and you can generate a lot more current a lot faster. You can generate higher cold cranking amps. The cold cranking amp rating that's what CCA stands for. That's on the label generally that says CCA. So the CCA rating on the battery determines its ability to produce amperage and however many amps at 32 degrees Fahrenheit. Okay, so the the CCAs are 0 degrees Fahrenheit. Just a correction, 0 degrees Fahrenheit. The CAs are at 32 degrees Fahrenheit. Okay, so when you charge an AGM battery, you have to charge it with a battery that has a specific mode for AGM. If you charge these batteries with something that is not designed for that specific battery, in the algorithms at which it charges, you'll destroy the battery. You'll burn it up in most cases. The other thing that you have to realize is that AGM batteries produce a higher voltage than SLI batteries. They produce generally right around 12.8 on the voltage, sometimes up to 12.9, depending on how strong that battery is. So it's very common to see a battery in like a BMW or a car that has an SLI battery in it that is literally, how do I say it? That is literally producing a little bit higher that might seem like surface voltage. And we'll talk about what surface voltage is and stuff in a little bit. But that battery does produce, AGM batteries do produce, or spiral, if you want to call it a spiral battery or an Optima battery or whatever you want to call it, it produces a little bit more voltage than the SLIs. Okay. All right. And then we have the deep cycle battery. The deep cycle battery, they are designed to provide a steady amount of current over a long period of time. And they can handle a complete drain down and a complete recharge, a complete drain down and a complete recharge. They are designed for that constant drain down, recharge, drain down, recharge. Unlike the SLI batteries that are not designed to go all the way down. When you get an SLI battery that's been all the way down, chances are there's some damage in the plates of those batteries and they need to be looked at and tested for state of health at that point. Okay. But if it's generally they're marine batteries for most cases, a deep cycle battery, they're meant to be cycled like that. That's why they're called deep cycle. Deep down into the low charge values, then bring them back up. Okay. They're also designed for repetitiveness of that constant thing. Okay. So moving on to the next slide here. So then we have the valve regulated lead acid batteries. The valve regulated lead acid battery, VRLA batteries, they're designed to be low maintenance and they don't require the regular addition of water to the battery cells because they do not require regular maintenance. The batteries are sealed, which means they will not spill if tipped over and inverted. You see these kind of batteries a lot in jet skis and motorsports where the motorcycle is going to be on its side because it's a dirt bike, or the jet skis upside down in the lake while everybody's swimming to get back to it and get on it. So you'll see these. The other types of batteries that are notable for that type of activity are the AGM glass mats. They actually make these small motorcycle batteries in AGM style. I know that's what I run in my jet skis, in my personal jet skis. Very good batteries. They've lasted, I get a good 2 to 3 years use out of them that way. It seems like the regular VRLA batteries, every year I was replacing them and putting in new VRLA batteries every year. Well, that gets expensive. So I tried the AGM motorcycle batteries. I've had great success with them. During the winter times, I pull them out of the jet skis, I charge them up properly, put them back in, they run great the next year. I don't know how long it'll be before I go, but I'm going on year 3 on a set of them, and they're doing extremely well. So been very happy with them. And then you have the gel cell batteries they're called because of their silicate-based electrolytes. They're called gel cell because of that. Typically, they work best for deep cycle applications like marine vehicles. Golf carts are a big one. They have a silicate base in them that allows for a deeper discharge and then a recharge. And they tend to produce this constant amount of voltage at that deeper discharge rate. So different types of batteries out there, and this one is one that's not made a lot of progress yet in the traditional automobile, but has made a ton of progress, obviously with Tesla, obviously with General Motors and Ford, and is becoming mainstream in their 100% electric vehicles, right? That's the lithium ion batteries. These batteries, while they're incompatible with the majority of the vehicles on the road, in recent years, there have been a number of automobiles that I just mentioned that are bringing them on. You'll see the Chevy Bolt when you come into lab if you haven't already seen it because you've been in another class and you've seen it in the shop. That Chevy Bolt that we have at the college, that car is designed with lithium ion batteries in it to run, and the battery pack is all lithium batteries. So it does extremely well, and they tend to last in the typical automobile for something like this. This here would be a like a marine application battery, but in the cars, the 100% electric cars, you're getting 10 to 15 years out of these batteries, or generally about 200 to 300,000 miles, and then the batteries have to be refurbished, the battery packs and assemblies, okay? So, or replaced, whichever it be. All right, go ahead, take a little break, get a drink, and then we'll come back and we'll start the battery service safety considerations that we need to talk about, okay? All right, guys, so break's over. Let's get started on service safety considerations, things to take about. You always want to adhere to these safety precautions when working on electrical components. Disconnect the negative battery cable first. Anytime you're working on a car with the electrical system and you're disconnecting the power, always disconnect the negative battery cable first. That's just a rule of thumb. It disconnects the electrical system in the proper process. Is what the manufacturers want. So always disconnect negative first, okay? Moving forward, wear eye protection. Absolutely necessary. When you guys come to lab, you must have eye protection on. You must have eye protection. If you do not have eye protection, then you're going to get dinged for that. So make sure that you absolutely have eye protection on, okay? All right. Next step is going to be the considerations of adhering to them. Never smoke or use open flames around batteries either, guys. Never, ever, ever smoke. Never, ever use open flames around batteries. If a battery is generating hydrogen and you put anything around it that can ignite it, you could potentially have a bomb in your face, right? So just don't work around batteries with flames or with cigarettes or with incense or anything that creates a flame. It's just not safe, all right? Okay, so battery and terminal cleaning. How do we clean the battery? How do we clean the terminals? What is the best way to do this? So what I'm going to show you here is that this is obviously unacceptable. Okay, that is an unacceptable terminal. It's rotted out. It needs to be replaced. Okay, many battery faults that come into the vehicle. In today's cars, we have fail codes that come into play. Fail codes will identify potential electrical issues, and we'll talk and learn more about those, especially when you get into advanced electrical, you get into engine performance, things of that nature. But fail codes can be generated simply because we have a bad terminal connection. If you look at the positive terminal connection over here, this is a loose connection. This is not a good solid connection. The terminal is not all the way down on the post. like it's supposed to be, and it's supposed to be tight, and this top is supposed to be flush with the post. If it's not, then it's not mounted properly on the battery, okay? So we have a bad corroded connection on the ground side. We have a loose, improperly fitted connection over here. And what's happened is that this terminal has expanded and come to the point where it needs to be where it too needs to be replaced. And the reason being is if you look at this right here, you can see that this is completely down as tight as it will go. And you'll also notice that these nuts are corroded a little bit and kind of in rough shape. So we're dealing with battery terminals that need to be replaced, corrosion that needs to be cleaned, all that kind of stuff. Things that we need to keep our eye on for. And we're going to talk about how that happens here in a minute. So looking at the battery maintenance side of things, if I look here, totally unacceptable, whether it be ground or positive, to have this type of scenario where battery cables are put into play. I'm going to do a video on how to properly make battery cables so that you can have a good battery cable design in your vehicle, and that video will be shown so you can learn how to properly make battery terminals for your vehicle. But this here is improper battery terminal construction. I call these emergency terminals only. Literally, that's what they're for. They're for emergencies. In the event that you need one in an emergency, it'll get you by, but it then needs to be replaced with a proper terminal in the proper format at a later date. This is not a proper terminal, proper format. This is a emergency terminal that was put on and left there, and now you can start to see the corrosion that takes place. This is a side post ground where it mounts to it, and this here is corroded and rotted and fallen apart. This ground where it bolts to the steel body of the car needs to be cleaned, maintained, and put back together properly so that it looks good too. This is where appearance does matter in a lot of cases, okay? So what we do to clean this stuff up. Baking soda. It doesn't have to be Arm & Hammer. We just put Arm & Hammer on the photo because that's the most popular, right? I get the stuff from Smart and Final for $5 or whatever. And this here is a battery terminal service kit. All of the components that are in this kit are hanging in our tool cabinets. In the red tool cabinets at the back of the classroom are actually now facing the shop, but the red tool cabinets that line the back of the classroom facing inward to the shop. Those tool cabinets have all of these tools hanging up in those cabinets. You can access them and use them to clean batteries. This particular tool is a post cleaner. This is a scrubber that can scrub brush that can be used. It's a brass scrub brush that can be used on the terminals. It can be used on the battery itself, but it's safe. Different size wrenches for different size batteries, and this one has a longer handle. Obviously, terminal pliers for corroded pliers to break terminals loose, to get terminals loose, and then a terminal puller so you don't damage the battery, pulling on that lead terminal in the battery at the top of the battery, okay? So if you're pulling on that lead terminal with something like pliers or something like that, trying to get the battery cable terminal off of the battery terminal, you could break the battery terminal internally in the battery and break it loose from the plates inside the battery and ruin the battery, okay? That's an extreme case, but you certainly need to be cautious with that, okay? So this here is a video that I'm going to play for you, and I don't necessarily like the whole video. It's 10 minutes long, and but there's some things in here that I'm gonna point out. So we'll go ahead and listen to this, and when we're done, we'll talk about it for a minute.
Hi, I'm Scott from the Automotive Service Garage in Alexandria, Virginia, and I'm showing you how to maintenance your car's battery. Now let's move on to cleaning your battery terminals. First thing you want to do is, of course, look at the battery, making sure that the terminals, where the terminals are oriented. Remember, your eyeglasses and your gloves. We're going to remove the cover and take a look at the positive cable. We can see that there's a lot of corrosion around the positive, where generally you get more corrosion than on a negative cable. So let's proceed with cleaning it. To do this, we're going to need a 10mm wrench to remove the terminals. Remember, the negative terminal is always the first removed and the last reinstalled. Again, sometimes you need pliers to gently nudge the terminal away from the battery post. Place them away from the battery so you don't get accidental contact. All right, now we've got our terminals removed. We can see that there's corrosion inside the terminal, which we couldn't see before, but we knew that there was going to be something based on what we saw around. So again, we're going to move the cable away so it can't make any accidental contact. And we're going to work on cleaning the battery posts themselves. First thing we're going to do, take a rag and clean off the excess.
I want to put a note in here. Do not take a rag and clean off the excess, guys. Unacceptable. Don't do it. One, you're contaminating the rag, filling it full of battery acids and stuff and junk that shouldn't be in a rag. That's a safety hazard for the shop. What if somebody picked that up and wiped their eyes in a worst case scenario? Super dangerous. Don't do that. There's a way to dilute this, and he should have at this point had a mixture of baking soda and water and poured on it and diluted all of the acids. Very first thing. Should have just very first thing, diluted all the acids and prepared to wash the battery down with water, okay? Unacceptable, so be cautious of that.
Now we're going to use this modified wire brush. There's a wire brush inside of here, which the battery post will go up inside of and make a nice, new, clean contact.
So let me see if you guys can figure out what he did wrong right there. On the very first terminal he cleaned, when he was done cleaning it, what did he do? He leaned down to the battery. You didn't see him lean down, but you could hear it. And he blew on the battery terminal post to blow all the stuff off. Again, why would you want to blow all that crap and all that junk all over your engine compartment or up in your face? Don't understand it, but what I'm trying to do with this video is show you the good and the bad, and YouTube is not always right, guys. So there's a lot of bad things in this video, and hopefully we can point them out as we go. So let's continue.
As you can see, the post now is nice and shiny. They're made of lead, so you can tell when they're clean and when they're dirty. The top of the post is slightly discolored. It's not a contact point, so it's nothing we really need to worry about. All right, let's move on to cleaning the cable itself. This is our positive cable, which we noted was the one that had the most corrosion. I'm going to take a rag, put it down under so that there's no way that I make contact with the post while I'm cleaning it. Now, there's several different products out there for cleaning battery terminals. This is the one I use, which is a spray-on, and as you'll see, starts to foam immediately. What it's doing is neutralizing the acid that's on the cable itself and removing or softening most of the corrosion. Now, at home, baking soda and water works good for this. You would actually take the cable, use a small cup of some sort, something that you're not going to reuse, and douse the cable in it. It generally takes about 10 minutes for this to happen. Now, if baking soda and water is not available, Coca-Cola works great.
To go with him in agreement on this, Coca-Cola will absolutely clean off the battery cables. There's some good acids in it. Another good one is Pepsi. They will clean it. And really, if you really want to clean it good, believe it or not, a Monster Energy drink. Monster Energy drink, I've tried it. It does an amazing job, but it needs to be the actual original green Monster to do it. It has all the stuff in it necessary acid wise, and it cleans those battery terminals like brand new. Absolutely amazing what it does. Good stuff. So that's a good use for that stuff if you don't have the baking soda and water, or the battery terminal cleaner that he showed that he sprayed on. So I do like the method of him putting a rag underneath there to capture all the stuff. The main thing is though, is if you're going to do that with that rag needs to be washed out and put into the soiled rag bin, where it's not going to be grabbed by anybody else. So or in some cases, just throw the rag away if you can do that. If you have the means to throw it away when you're done, so it doesn't end up in the wrong hands, doing the wrong thing and hurting somebody. It's a good way to do the maintenance, but you have to take that judgment call, use wisdom in what you're doing, pay attention. All right, moving on.
Again, 10 minutes with the cable in the end, and you'll be fine. Now I'm going to apply the cleaner to the negative cable. Let that soak. We sprayed the cleaner on, and we can see that a lot of the corrosion has come off. What I'm going to do now is I'm going to take a small wire brush, and I'm going to go around the terminal, getting off anything else that the cleaner didn't actually remove.
I want to highlight, you'll notice that on the terminal, there's still some green decay and stuff that he didn't get off with the brush. What you do is you go back and wash it again with baking soda and water after you've brushed it. Make sure that you get all that corrosion diluted and brushed off and cleaned off. The more detailed you can be, the better service and maintenance results you're going to have on your terminals, okay?
We get that done, we get everything loosened here. I'm going to spray them one more time just to make sure that I've got everything off. Terminals look good now. The positive is still bubbling a little bit, but we've got 90% of everything off of there, which should give us a good contact. Now we'll start with the negative cable here. We'll clean off the cleaner. And as we can see, the terminal has changed colors, which is indicating that the corrosion is all removed and we're down to the bare metal on the terminal. Now the positive post. And that looks pretty good. If you noticed, I used rags underneath of these battery terminals while I was cleaning them, just to make sure that none of the acid that I removed from the cables were to drip down on any components in the car. You're wearing gloves and eyeglasses to prevent that from getting on you. You certainly don't want any of this getting into any items on your car. Again, before installing, we're going to use battery terminal protectors. We've cleaned them, now we want to keep them that way. The red terminal, of course, is going to go on the positive post.
Take note to the fact that he put that red terminal barrier over the top of some corrosion that was not cleaned off the battery. If you look at this right here, see all this stuff? This should all be washed off. And underneath here, there was a bunch of white stuff too. That should all be cleaned and gone, guys. The best thing to do is take some just regular soap and water after you've neutralized all of the acid. Just some soap and water, like a wash mitt from a car that you wash your car with, that maybe you keep for just washing under the hood stuff, right? And wash it off. Clean the battery. Clean it. And wash it off. Hose it off and let it all run out down the driveway or whatever you got to do. As long as it's been neutralized and completely eradicated, it's not a toxic product at that point. If it's been neutralized properly. Now, if it has not been neutralized, you can't just wash it out onto the ground. That's a toxic product. So you can't do that. But you've got to clean the battery. You've got to clean the battery. The best thing to do is not even wash it off on the ground. My suggestion would be, and this is my official suggestion, is to put a drain pan underneath the car and underneath the battery area and wash the battery off and let it go into the drain pan and capture that water and dispose of it properly in accordance with the regulations of your shop and the state and environmental concerns. So get rid of it properly and clean the battery properly so that it's maintained properly. So there's, again, another mistake that he's making and showing here that I don't agree with. All right, so pay attention to that as we go. So I'm going to continue on here.
And a black terminal pad on the negative post. Again, remember, negative terminal is the last terminal connected. Now I'm going to install the positive cable. I'm going to make sure that we push it down so that it's oriented correctly, all the way down to the top of the battery post, slightly protruding through the terminal end. Last but not least, the negative cable. All right, we've got our terminals installed. Now we're going to seal them. It's a battery sealer which you can get in an auto parts store, which will make a seal around the battery post, even further preventing acid from getting on the post. Remove any covers that we took off to access the terminal. And again, look around to make sure that anything we moved or any cables are oriented correctly. Now that I've showed you how to clean your battery terminals and put them back on, next we're going to show how to jump start your car properly.
I'm going to question whether or not he shows how to jumpstart the vehicle properly. I will tell you, I watched the video and he does not jumpstart the car properly. So there was a lot of mistakes in this video, guys. A lot of things that you don't do, some things you do. But I wanted to show this video for the sheer purpose of you guys needing to understand and being able to common sense wise sift out the good from the bad on this YouTube stuff. This was good enough that it could convince somebody to think that, hey, yeah, we're in good shape, but it was not good enough to keep me convinced and keep me engaged in the process. So I would tell you that there was a lot of mistakes, a lot of things. The biggest thing is, guys, you got to get everything clean, not just like roughly cleaned. If you're going to do a battery service, your name, your reputation, everything you do is on that. So I don't know if you want that reputation. I don't know what type of reputation you want to have as a technician. Personally, I want my work as a technician to be a reputation of quality work, clean work, and neat and tidy work that brings a positive reassurance to my customer A customer is reinsured not only by the way the car runs when it's done, which all of the cleanliness of that vehicle affects how it runs, but they are reassured by the appearance of the work you did and by the way that that work affected their vehicle in a positive way or if it still has issues. So keep that in mind, and it's just real important to make sure that you're doing the job to its fullest and getting things done the way it should be done. All right, so we're going to move on to our next slide here. Okay, so battery maintenance. When we're doing this, we need to look at the battery hold downs. We need to look and see if the battery hold downs are in place, if the battery brackets are corroded, if they're rusted, if they need to be replaced. There's several different types of battery hold downs. This is a wedge type hold down that has one bolt that goes through it and wedges the battery into the tray over here. And on the tray itself, right here, the battery lip at the bottom of the battery sits down into it. And then this wedge goes down, and you can see how it wedges the battery and pushes it back into this little lip. And as that wedge pushes down on the battery, it pushes it back into the tray and locks it into place so it can't come up and come free. A lot of times they're missing. People didn't want to fight with putting them back in, or they broke or whatever, and they just let the battery sit in the tray by itself loose. Not good. You don't want a battery bouncing around under the hood. You don't want a battery bouncing into the engine fan. You don't want a battery bouncing into the hood of the car and shorting out and arcing while you're going down the road. Could you imagine the explosion factor of a battery arcing out because it's bouncing against the hood of the car as it goes down the road? A lot of things. When a battery hold downs are broken or missing or corroded and damaged, they have to be replaced, guys. You guys are responsible as a professional technician, as a professional individual. You have the responsibility to notify the customer that this stuff has to be done. It's a safety factor. If they deny it and they refuse the work, that's fine. That's their choice. But you have the responsibility to write it down on the work order that they denied it and why you recommended it. That's to protect yourself in the event that something happens, okay? So keep that in mind. And you're doing your customer a service at that point. That's what's important too, okay? So moving on to our next slide. Using Pepsi. Very good idea. Using Coke, it works, guys. It does work. I don't know if you want to use what you drink and lose your beverage, but like I said, Monster energy drinks are phenomenal at cleaning battery terminals. It makes them look brand spanking new, guys. It's a really crazy thing, but it does. Makes me wonder if you want to be drinking that stuff and ingesting it when you see what it does to a battery terminal. But it's good. But baking soda is the best thing. Okay. All right. So battery voltage test. Let's take a little break. You guys go get a drink and come back, and we'll get started on this section. All right. So break's over. Let's get started. So state of charge. What is the state of charge? State of charge is critical. State of charge is a mandatory thing that you need to be watching because it drastically affects the cars today because of the computer systems on the car. So something you need to be paying attention to. Today's batteries are good enough that they will run until they are completely done. And I'm going to share with you one case example, okay? So I work for Bosch, Automotive Service Solutions, and my boss decided he wanted to test the validity of a conductance and a capacitance tester that we had just designed and released to the market. And so he has a Cadillac CTS 2008 at the time. Brand new car, well, not brand new. At the time that we were releasing the tester, the car was 2 years old. So he wanted to test it. It was his wife's car. And he throws the tester on it. The tester comes back and says, the state of charge on the battery is 25%. And basically what that's meaning is that this battery and the state of health of this battery was pretty much zero, that this battery's toast. This battery's done. It's going to die. You're living on borrowed time, and probably most likely it's going to die in the most unopportunity, or I guess the most, how do I want to word this? The most inconvenient time. That's the way I want to word it. Most inconvenient time. So, He leaves it and goes, yeah, I'm just going to leave it. Didn't say much to his wife about it, I guess. And so we're in Minnesota as a group, co-workers, on a company meeting, and he gets a phone call from his wife. He lives in Alabama. This is in the middle of July, and he gets a phone call from his wife. She's at the grocery store with their daughter's birthday ice cream cake. Alabama, 94 degrees with 100% humidity, or 95% humidity at 100 degrees outside. And this ice cream cake she has outside, and the car won't start. And this was 2 weeks after he tested it. And he says it's just going click, 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 click. So just enough to make the starter click. So the battery had died. And it died, yes, in the most inconvenient time, right? So we're all just kind of laughing because we knew what the situation was. But that one was to prove the validity of that tester. That tester worked. It said 2 weeks prior to that battery being bad that, hey, yo, you're on borrowed time, dude. Make sure you replace your battery. But he chose to let it go because it could handle a load. It could start the car, but really the battery was not good. Okay. So the testers that we have today do a different testing style than what we used to have back in the day when we were technicians in the shop as young technicians. And the technologies have changed, and they're a little bit more scientific technologies. And do they work? Certainly they work. Are they always perfect? Certainly not. They're not always perfect, but 98% of the time they're on the money. And I know that because of the relationship I've had with them in the industry through all of the customers that we supported and technically supported in the field prior to me becoming a technical instructor here at the college. But I can tell you that there is absolute science behind the state of charge. Okay, we test the battery voltage with a voltmeter. This is how we do it. We take and test the battery with a voltmeter. Okay, does the voltage necessarily indicate whether the battery is satisfactory or not? Absolutely, it does. Let me take that back. Absolutely not. The voltage doesn't necessarily indicate whether the battery can be can do its job satisfactorily. The voltage gives us a good indicator of what state of charge is. Okay, it does not give me more information than the visual inspection. It just tells me that, hey, if I have 10 point something volts in there, it's very likely, right? Let's say I had 10.5 volts, it's very likely at that point that I have a cell in the battery that is not working, period, right? Because take 2.1 away from 12.6 and so on, comes down to 10 something, right? So obviously I have a cell in the battery that's not producing anything, right? They're all in series at this point. So that tells me that I have a battery that's got an issue with the cells internally, okay? The test is commonly called an open circuit voltage test. So earlier, I wrote something on the slides at the beginning of this presentation, right? And I'm going to write it again for you because it's that important. So here we go. There's something that we need to be aware of, and it's called OCV. During lab, in every one of your electrical labs, I expect you guys to be checking the OCV. The OCV of the battery should be 12.6 to 12.8 max. If it's higher than 12.8, we have what's called surface charge, okay? Surface charge means that there is a charge on the surface of the battery and the surface of the cells of the battery that needs to be removed. That is not usable charge. It's really unusable, but it's measuring and throwing your measurements off. So it's an unusable charge, but it's making it look like it's more than it is, right? So you need to get rid of that. We get rid of the surface charge by turning on the headlights or something to that effect until we pull the battery down to 12.6, 12.7, then we shut the lights off and make sure that it maintains that at that point. Then that guarantees us that we got rid of the surface charge and we're not getting skewed readings, right? So keep in mind that 12.6 to 12.8, that should be where you're at for open circuit voltage. Again, OCV, open circuit voltage. Okay, guys? So moving on, and because I'm really bad about this, if I don't do this now, I'll probably save it with that on there for the next presentation. So I have some other slides that I didn't clear off, but all right. So if the battery has just been charged or the vehicle had been driven, that surface charge is going to be on there, okay? We need to make sure that we get that surface charge off. I'm not going to explain this slide again because I just did it, right? If we are doing what I do want to highlight is right here actually. If we are doing a capacitance test, we must get rid of that surface charge prior to the capacitance test because it will skew the capacitance test. The capacitance test is the testers. I'll do a video on a capacitance test for you and post that in here so that you can watch that video and so you know how to do it when you get to lab as well. Okay, so this test can drastically affect what you are doing and can drastically skew your capacitance test results. Okay, so you've got to get rid of the surface charge to get rid of that, to get that capacitance test accuracy. A good way to get rid of the surface charge is to do a massive load test on the battery using the old load test method. That puts a massive load on the battery real fast, pulls it down, and gets rid of any surface charge real quick, and then allows the battery to recover. Then you can run a capacitance test and find out if it's going to be able to handle the recovery rates. See, the load test won't tell you what your recovery rates are like a capacitance test will, okay? All right, battery voltage test removes the surface charge. Obviously, to remove surface charge, turn on the headlights on high for 1 minute. Use the load tester and load test the battery with a VAT40 or something like that with a load tester. That way it gets rid of that surface charge and then it can run a capacitance test. The other thing with running a capacitance test that's really super important is to make sure that you have lead contact with the clamps on the capacitance tester. I'll show you that in the video when I shoot the video for capacitance test. Super important that you watch that and understand how to hook up the capacitance tester properly, okay? Battery voltage test. Read the voltmeter and compare it with the state of charge of the battery. The battery voltages are shown for a battery at or near room temperature. So that is 70 degrees Fahrenheit, guys. 70 degrees to 80 degrees Fahrenheit is considered room temperature. Okay, so make sure that you're testing it at or near 70 to 80 degrees Fahrenheit to be able to get regular, typical open circuit voltage. One thing that I want to talk to you about is open circuit voltage is measured at 32 degrees Fahrenheit at freezing. Okay, so OCV is measured at 32 degrees Fahrenheit. That's what the manufacturers of the batteries measure it at. So at 32 degrees Fahrenheit, it should be 12.6 volts. If it's if it's 70 degrees, that battery could very easily produce 12.8 volts. It is not uncommon for a battery to produce higher voltage in warmer temperatures because electrons can now move freer and faster through the battery than if it's frozen, okay? So it's 12.6 volts at 32 degrees is good. 12.6 volts at 70 degrees is good too, okay? That's still the same, but at 32 degrees it should be 12.6 volts, okay? That's a good battery. All right, so moving on here. A voltage reading of 12.28 volts indicates that the battery is not fully charged and should be charged before testing. Now, what that also means, there's another caveat to this that I need to highlight. Okay, 12.8 volts or 12. Let's take this down. 12.28. 12.28 volts. 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 12.28 12.28 volts. And you should know this from Intro Auto. 12.28 volts, guys. That battery is how far discharged? That battery is 75. Whoa, crud. I can't use this pin very well. So that battery is literally 75% discharged. Okay. Of course, my D doesn't look like discharged. I'm just going to put it like that. Discharged. 12.28 volts. That battery is 75% discharged. Okay. There's a chart that you guys have from Intro Auto, and I'll give it to you here as well. You'll see it a couple times in this class. But 12.4 volts, let's just do this, 12.4 equals how much discharged? 25%. That means that 75% of the battery is available, okay? 12.2 volts means that 50% of the battery is available. And 12.0 volts means that 0% of that battery in the way of a state of health or state of charge. For whatever reason, this board does not like me writing zeros. Okay. So 12 is 0%. Is 0% at that point, okay? All right, I'm going to take this off and I'm going to erase this. All right. In this case, I'm going to ask a quick question. 12.6, good or bad? You answer the question, right? 12.28, don't condemn the battery yet. Charge the battery and see if it maintains that 12.6 at that point. You have to always charge it when it's questionable at this point, because it could just be that it's been drawn down and it needs to just be charged back up. Okay. Do not use the alternator on the vehicle as a charger. Emphasize that. Do not use the alternator on the vehicle as a charger, guys. Okay. Always use a battery charger as the charger. Okay. All right. Battery load testing. Test procedures. Hint, hint. There is nothing hanging on this load tester in our shops with these steps. These steps are given to you in your lab book, and they're given to you right here. So take notes. Okay. Step 1, determine the CCA rating of the battery. You need to know what the cold cranking amps of the battery are. Okay. Again, I will show this. I will demo this in the lab. You should already be somewhat aware of this and know what this is from Intro Auto. You probably didn't do this test in Intro Auto, but you should be aware of it, okay? So, proper electrical load testing battery is 1/2 the cold cranking amps, and I want to emphasize that right there, and I'm going to probably get a highlighter on that because it is, okay, proper electrical testing load to test the proper electrical load to test the battery is 1/2 of the cold cranking amp rating, or 3 times the amp hour rating, with a minimum of 150 amp load. So the battery has to be loaded to at least 150 amps. That means if the battery's cold cranking amps is 150 amps, you're actually going to put it to 100% load at that point, okay? But you're never going to find that. Usually it's 500. The lowest I've seen, I think, on a car is 450. So, but half of 450 is 225, right? So I meet my minimum 150, okay? So 150 or 1/2 of the cold cranking amps of the battery. So a minimum of 150. If I have an 800 cold cranking amp battery, that's 400 amps that I'm going to load that battery to, right? On a load test, okay? Step 2, connect the load tester to the battery and follow the instructions for tester. The battery should stay above 9.6 volts. If it fails, it is bad or undercharged. Now, what's not noted here that I'm going to tell you verbally, okay? What's not noted here that I am going to tell you verbally is that this load that we're talking about right here, this load, the battery should stay above 9.6 volts. For how long should it stay above 9.6 volts? For 15 seconds. I should be able to load that battery for 15 seconds and keep it above 9.6 volts under that load on a load test, okay? If it doesn't do that, we have to hook up a battery charger, recharge the battery, and test it again, because we have to replenish the electrons we took out. We don't have an alternator doing it. We don't want our alternator to recharge the battery. The alternator is not a rechargerator. It is not a recharger. It is not a recharge alternator. It is not whatever you want to call it. Hopefully you got the hint. It is a maintainer. It maintains the battery and supplies the electrical to the vehicle for all of the systems to be able to operate properly on the vehicle. When the engine is running, the alternator is the main power supply to the vehicle, okay? It is not a recharger for the battery. And in fact, if you are using it to recharge the battery, there's a chance that you could destroy your alternator and ruin it, okay? Because the alternator is then working way harder than it needs to be, because it's still running all the electrical and electrical components in the car as well as charging your battery. So your alternator is running at max load. The more electrons we move, the hotter things get, the faster things melt. So do not use the alternator to recharge the vehicle. If your battery went dead and you jump-started your car and you got a 5-hour drive, that's another story, right? It's probably going to be charged by the time you get home. The alternator is going to take care of it. Not that you wanted to do that, not that that was the ideal condition, but if you got a 5-minute drive across town or a 10-minute drive across town, when you get home, get a battery charger out and put on your car for a couple of hours and charge that battery back up, because the alternator didn't do it going across town, okay? So think about that. But here, you connect the load tester to the battery and follow the instructions of the tester. Over here on the tester, you will see that there is a few things that need to be switched. Are you testing the charging system, or are you testing the battery by itself? You need to know what you're testing, and you need to flip that switch right there. This little switch needs to be tested or switched. This switch right here needs to be switched to the proper mode, okay? So make certain that you switch this switch to the proper mode. Don't leave it in the wrong mode. The other thing is you need to make sure that this switch over here is switched to the right mode too, okay? Don't leave the switches in the wrong modes. If you're not sure how to do it because the demo wasn't sufficient, come see me, right? Or come see the instructor of this course. If it's Mr. Flint or myself, it's going to be Mr. Flint, myself, or potentially Mr. Range. But it's going to be mostly me, because this course is my responsibility as my primary instruction. So this, come and see me. Don't allow yourself to just sit there and wonder. Now, don't come and see me if you didn't do your due diligence and try to figure it out, because I'm not just going to hand it to you. But I don't want you destroying something on a car, or destroying something on the tester, or destroying yourself in the process, okay? So please come see me, okay? All right, moving on. Battery load testing, step 3. Apply the load for a full 15 seconds. Observe the voltmeter during the 15 seconds, and it should stay above 9.6 volts. We've already talked about that, right? Okay, so moving to the next step. Okay, going there. Next step. Step 4, repeat the test. Wait 30 seconds between the tests. Many of the battery manufacturers recommend 2 tests. One to remove the surface charge, and the second, truer indicator of the battery condition. Now, keep in mind, I did say here that you would sometimes use this load tester to remove the surface charge. If that's the case, that's all you're going to do, right? You're not going to throw a second test on it, because then you're going to be pulling the battery down to a point where it can't recover properly, and you'll get an inaccurate and incomplete capacitance test. So if you're going to use a capacitance tester and you have surface charge to remove, use this tester. It gives you two baselines. It gives you a good baseline on the load and the ability to do a mass saturation of testing, right? And can it pass a mass saturation, a mass draw on the battery? If it passed that, then you're great. Yeah, you got rid of the surface charge. Let it recover for a good 2 or 3 minutes before you do a capacitance test, and then hit it with a capacitance test. Manufacturers of capacitance testers are actually saying let it sit for 10 minutes before you hit it with a capacitance tester. So again, the manufacturers, the capacitance testers, I kind of go with them on that, simply because I listen, but sometimes they're not always right. Doesn't mean they're always right, but a lot of times they are. And being that they are the ones that built and designed the tester and know how it works, it's probably a good idea to let it sit for 10 minutes after removing a surface charge like that, and then hit it with the capacitance tester, okay? And when you do that, the other thing you need to do is make sure that all the lights are off in the car. Make sure no loads are on in the car if you're going to use a capacitance tester of any kind. Everything has to be turned off. So in some cases, it's almost better to just disconnect the negative battery cable, let it sit for 10 minutes, hit it with the capacitance tester, test it, and then hook the car back up. But if you do that on today's cars, that may be a bad thing because you may lose radio settings, presets, all that stuff. So you need to make sure you have a power supply of some sort to supply power back to all those devices, okay? And we'll talk about that in the lecture video and the lab demo video, okay? All right. 27. This battery has a cold cranking amps of 550 cold cranking amps. So 680 amps and a low temperature test. The load test amperes of 270. Listed on the label. So for example, right here, cold cranking amps 680. Load test amps. They don't normally give this to you. That's a given right there. That's like okay. So in that case, cold cranking amps are 550. So half of the cold cranking amps are really 250. But they're saying that they want to do half of the cranking amps, which is 0 degrees Fahrenheit. So, or which is 32 degrees Fahrenheit. So you go with the cranking amps, half the cranking amps at 270 to test it under a load test. Okay. Always look for the label. Always look for the cold cranking amps. Look for the cranking amps. Look for the load test amps. We're also going to talk about reserve capacity and a few other things through the multimeter essentials lecture when we talk about that. But there's some things for you to think about. Test procedure. Step 1, connect the unit to a positive and negative terminal of the battery using an electronic conductance tester, okay? If the testing of the side post battery always uses lead adapters on the side post, never leave the side post terminals in if you can. Always disconnect them and hook up the lead adapters that come with the tester for side post, guys. Lead contact with the capacitance tester is super critical. Having contact to the lead of the terminal is super important. And on a side post, you can't do that unless you disconnect the cable and put in the lead adapters that come with the tester to be able to do it, okay? So make sure that you do that. Step 3 with the conductance tester determines if the display tester determines and displays one of the following: a good battery, charge and retest, replace the battery, bad cell, replace. Some conductance testers can check the charging cranking circuits. So I'm going to quickly pull up here a website that I need you to go to, and you can download this app to your phone as well. So let me get this pulled up. Hang on for just a minute. I'm going to quickly do a pause, and then I'll come back in. That way you guys don't hear me banging on my keyboard as I pull up the website. All right, so the B2Q Technologies is the website, and here's the B2QTECH.com. So it's B2QTECH.com. B2QTECH.com. Okay, and that tester Right here is a tester you can buy. It also has an app that downloads to your phone. I have this tester at school for you. That's my personal tester. I bring in and let you guys play with it for conductance testing. It's a fun little tester. Believe it or not, when I'm doing mobile work around town and helping shops and stuff, I carry this tester with me, guys. It's pretty dang accurate. You can get a lot of results. It emails it right to the customer. It emails the results to you if you want to keep it. It keeps the results on your phone for history. It works with Apple. It works with Android. Super good little tester to have in your toolbox. You're going to spend about 190 upwards to $250 for it out there on Amazon probably, but it's a very good tester to have. It's in the app. You pull up the app, you open the app. It shows here that the battery is at 12.8 volts. It tells you right now what that's telling you is that at 12.8 volts, the little key symbol's telling you, hey, go start the car, because it's going to also measure the diode tree and the alternator and see what the diode tree and the alternator is doing and how it's working and whether or not it's outputting properly, or do you have a potentially weak diode or not. And if it flags that, I wouldn't necessarily take that as doctrine. It just means that I would go and look and see if I have bad diodes and perform tests that way, right? To do that. But super good little tester, kind of cool to have in your box, okay? Fun to play with. And I will be honest that it's been pretty dang accurate with this little replace now, because it gives you the state of charge and the state of health of that battery. And you have a pretty good read on that battery when you run that test, okay? So moving back over to the PowerPoint, let me erase all this stuff here and let's get started on talking about the conductance testing process, okay? So this is the conductance testing process from the OTC tester. And I have this from when I worked for Bosch and OTC SPX. It was first SPX, OTC Tools, / owned by SPX, Seal Power Corporation. Seal Power Corporation then sold us to Bosch. That's how I ended up working for Bosch for 3 years. So really, I just say it was Bosch because that's who I left when I left. It was Bosch. But SPX created this tool, or OTC created this tool. It's quite popular and it's been pretty accurate. A lot of stores and a lot of quick lubes and a lot of companies bought this tester and put it into their arsenal of equipment. And here's how it works. So I'm going to have multiple testing. So meaning more than one test within 3 minutes, this tester does. It can give improper test results, obviously, if this tester is not hooked up properly to the battery. If I don't have that lead to terminal contact with the tester lead terminals, I could end up with a bad test, okay? So the conductance tester, or any combination of the sequence of testing with the same time within the same time frame. So here, what happens is the first load, okay, VOCV, it takes the first load right here, and then it holds that load and watches the recovery rate for a minute. Then it hits the second load, okay, and it comes down and holds it, and then it watches the recovery rate for a certain amount of time, and it does a mathematical equation and tells you what the state of that battery is, okay? So below is the diagram of explaining the recovery. Keep in mind that they manipulate the recovery if we keep adding amps and ticking the test and tricking the test results. So if you keep adding result or keep charging this battery and adding amperage, you're going to get a different result every time. So it's important to do what I said when you're testing these with the capacitance testers. There's two or three things here that I'm going to mention that are real critical when you're using the conductance testing. Okay, number one, there cannot be a surface charge on the plates of the battery, and that's measured by measuring OCV. It cannot be, if it's an AGM battery, more than 12.8 volts. If it's a SLI battery, 12.6 to 12.7 if it's 70, 80 degrees outside, 12.75. You want that battery pulled down as close to 12.6 as you can get it, okay? So, first step, if it's 70 degrees outside or warmer and it's a SLI, right? SLI battery, 12.6, as close to 12.6 as you can get it on the low side. If it's below 12.6, then the battery probably is going to fail the conductance test at some point, or it's going to tell you that it is good, but it's low on charge, okay? The other component to this is you have to get the leads, the clips, the clamps to the battery tester need to be on the battery. Lead terminals. They need to be lead contact, okay, to the battery post. The closer you can get to the lead of the battery post, the better. Preferably on the lead of the battery post. If you have lead terminals hooking up, you can use those terminals because they're lead. You'll get a good connection as long as they're clean. Okay. And number 3, don't test and then charge and then test and then charge and then test. You're going to have a different result every time if you do that. So the point is with conductance testing is that we want to test the battery in its normal state of operation, not its shop state of operation, its normal state, how the customer uses that car. They drive the car, they pull into their garage, they park, they leave it there for a half hour, they leave it there overnight, whatever it is, right? I want to pull the car into the shop. I want to let it sit for at least 10 or 15 minutes. I want to make sure that all the surface charge is gone before I let it sit for 10 or 15 minutes. So I make sure I get the surface charge off right away. First thing I do, pull in the car, pull the garage, pull in the shop, open the hood, make sure that all the lights are out, including the hood light, right? Make sure all the lights are out, check my OCVs. If my OCVs are high, I'm going to clear it because that means I've got surface charge. Get the surface charge off. Once the surface charge is off, I'm going to let it sit for 10 to 15 minutes. I'm going to make sure that I get my terminals on lead to lead contact, right? Once I've got lead contact, I'm then going to run the conductance test. And I'm going to run it one time. If it fails, I can potentially run it again, but I've got to let it sit for at least 5 or 10 minutes in between and then run that test again. If it fails a second time on a conductance test, guys, I'm telling you, it's been 100% for me in my career. 100% of the time, it's been right. It has not ever failed me in that process, okay? There's a lot of, how do I want to say it? Certainly a lot of individuals in the industry that don't agree with this testing because they've had the bad experiences with it, and that's fine too. That doesn't mean that they're wrong. They're sharing their experience, which was different than my experience. So it's important to not discount what they say, but certainly in today's day and age with the electronics we have, this conductance testing is very, very finite. And so there's a very fine accuracy to it, and you can skew that test by making the wrong mistake in the testing process, okay? So be careful with the testing process, be accurate with your testing process and the conductance testing. All right, I'm going to play this video from OTC on the one-step charger. This one-step charger, I have one of these. I used to leave it at the college. I don't leave it at the college anymore because everybody that used it just could not respect it like it needed to be. This is a very, very, very expensive charger. You'll see this in CarQuest. You'll see this in O'Reilly's. You'll see this in the major auto parts stores. And they're, depending on the type of deal they struck with OTC, anywhere between $3,500 up to $6,000, guys, depending on what accessories they have and stuff. The tester, it does a battery analyzing, a conductance test, and then it brings the battery to a charged state that would be good to be able to test the battery again and test it again and finds out whether or not it can actually hold the load like it's supposed to. And then it does a load test on it too. So this is a very accurate tester. It's called the Arbist tester. Bosch now owns this technology. Auto parts stores use it for one reason, and it's because it's very accurate. And when they're dealing with warranties on batteries, there's a lot of dollars tied up in those batteries and their warranties. So they hold on to it, okay? And they hold on to that technology. So be aware that this tester is out there. It's very much so like the conductance testers that you're going to use on campus in lab, and except for the fact that it has a charger built into it and it has a load test built into the process. But I'm not bringing it back to campus for you guys to use simply because it is me that ends up paying to fix my tools for other people to use and not take care of. So I'll play the video. Hopefully you guys can get the concept behind this tester, but know if you're working in a parts store, you are going to in fact come across this and use this probably. Okay, so I'm going to mute myself and let you guys watch the video.
The one-step battery charger and analyzer incorporates several sophisticated testing and charge functions into a single non-portable benchtop unit. In this video, you will learn how the one-step can help you assess the condition of your customer's batteries, automatically provide a charge if needed, and determine if the battery needs to be replaced or can be returned to service. Here are some of the many features the one-step provides. Automatically determine if a battery is good or bad. Charge a battery in less than 1 hour. Indicator lights and on-screen progress prompts show the progress of the test. Each testing step features easy-to-follow on-screen instructions. The one-step is shipped with a charging stand that has an integrated charging chamber. This stand must always be used with the one-step. To complete the assembly for the battery charger and analyzer, follow these steps. The one-step will arrive in 2 separate shipping packages. The larger of the 2 packages contains the stand. Unpack this first. Minor assembly is required. Unpack the one-step and place it on the top surface of the stand. Connect the sense cable and charging cables into the appropriate ports on the rear of the one-step unit. Connect the power cord to the power input connection on the rear of the one-step. Note that there is a 110-volt power receptacle located on the back of the one-step. This is only intended for powering an external printer. Do not use it for any other purpose. You will notice that there are additional ports towards the front of the left side. These are for future use and will not be used at this time. Find a suitable place in your store to locate the charging station. It should be in an area where customers can observe the test. You will need to use a 120-volt, 60 Hz, 15-amp grounded wall outlet. An extension cord should not be used. When plugging the power cord into an electrical outlet, avoid wet floors to prevent electrical shock. Plug the one-step into the outlet. Let's take a moment to tour the battery charger and analyzer. The compact flash card port is used to program any future updates for the unit. The new software would be furnished on a flash card. The on-off switch provides power to the battery charger and analyzer. Press the breaker switch to reset the connection if an electrical overload causes a break in power. Use the number keys to enter numeric information. Press the clear key to remove information entered onto the display or to stop the battery testing procedure. Press the go key to start a test program. Press the up-down keys to scroll up or down to the next line on the display window or go to the next screen. Press the menu key to select the main menu. Menus and input screens are shown on the display. The status lights indicate that the battery charger and analyzer is powered on, a test is in progress, a fault is found, and the battery is bad. Or the testing procedure is complete and the battery is good. The bad light is red and the good light is green. Connect the battery clamp test leads to the battery post to apply voltage measurement and charge load. Make sure you review all the safety precautions included in the printed operator's manual supplied with the one-step. Remember, working in the vicinity of a lead-acid battery is dangerous. Batteries generate explosive gases during normal operation. For this reason, it's crucial that you take the appropriate safety precautions outlined in this video and in the user's manual each time you use your battery charger and analyzer. Always charge the battery in the supplied charging chamber, with the door securely closed. The chamber is designed to contain debris and acid in the case of an explosion. Never open the chamber while the battery is being charged. Do not charge batteries that have physical defects, such as a damaged case or terminals. Do not charge a frozen battery. Since it can be hard to tell if a battery is frozen, let the battery warm up first if you have any doubts. Personal precautions. Wear complete eye protection and clothing protection. Avoid touching your eyes while working near the battery. If battery acid contacts skin or clothing, wash immediately with soap and water. If acid enters the eye, immediately flood the eye with running cold water for at least 10 minutes and seek medical attention immediately. Never smoke or allow a spark or flame in the vicinity of the battery. Be extra cautious to eliminate the risk of dropping a metal tool onto a battery. It might spark or short circuit and cause an explosion. Press the on-off button to power up the battery charger and analyzer. The power status light will light up. After powering the unit, the first screen that appears is the language selection. The default language is English. The unit will default to English each time it is powered down. Spanish and French are also available. Press the number 2 key for Spanish and the number 3 key for French. To continue in English, press 1. Press Menu to access the Functions menu. These options are factory set and do not need adjustment.
All right, so I'm going to jump over to the next slide where we talk a little bit more about this. So this here is the one-step charger continuing. So I will move on to right here, battery charging procedures. So that pretty much walks you through the test functions of the Arbist charger from OTC. And now we're going to talk a little bit about the chargers that I personally like, Associated chargers. Highly respected charger in the industry, super high quality, have nothing negative to say in any way about Associated chargers. These guys are definitely a leader in the industry for chargers. We have one of them here at Bakersfield College. We have a multiple variety of tools that you guys get to use to play with to determine what you like best. But my experience being in this industry and being at a lot of shows and being with a lot of professionals in the industry, Associated holds the highest standard and the highest reputation in the industry when it comes to the chargers. So I'm going to go ahead and play this video. You guys can watch it and get the information on this. And he also talks a little bit about AGM batteries. Pick up on what he says. Gary Mackey used to be a co-worker of mine at Bosch. He too left Bosch and went to work for Associated. But Gary Mackey is a super nice guy, super educated on this stuff. And I personally like Gary, and he did a great job with this video. So this is good for you to watch. So here we go.
Hi, I'm Gary Mackey with Associated Equipment, the industry's leader in smart battery charging technology. Wanted to talk to you today about a change that's taking place in automotive service today. Vehicle manufacturers, from domestic manufacturers, Asian, European, as well as motorsport manufacturers and off-road equipment manufacturers, are trending to a new battery type referred to as AGM, or absorbed glass matte batteries. These new battery types are built in two configurations, either spiral technology or flat plate technology. In either case, these batteries are showing up in literally from every manufacturer on the market today. What do you need to know about these new batteries? Well, first of all, you should never charge these batteries with a conventional battery charger, even if it's an automatic charger. An automatic charger today, typically on 12 volt, will put out 16, 17, 18 volts. AGM or gel batteries should never be charged at more than 14.4 volts. You can damage an AGM battery in as little as one charge with a conventional charger. Associated's developed a new line of Intellimatic smart chargers that are available in size ranges from 10 amp all the way up through 70 amp. Let me show you a little bit about how these products work. What we have here is Associated's newest Intellimatic smart charger model, ESS 6008. This charger is loaded with features. First of all, it's a 60 amp charger, 70 amp power supply mode, and it delivers up to 270 amps of boost assist. This charger also has a mode called deep discharge recovery. It will detect batteries that are heavily sulfated or deeply discharged. Most battery chargers, even if they're automatic, if the battery is very, very low or completely dead, will not start. This charger has a function called dead battery override button, and you just hold the battery button down for a few seconds and basically it'll start the charger. This charger also has a function called battery diagnostics. During the first 15 minutes that the charger is hooked to a battery, it actually goes out and tests the battery 4 times. In the event that it is seeing that the battery is not holding a charge, you will get a flashing red light which indicates that the battery is not holding a charge. In addition to charging all types of batteries, this charger also performs a function called power supply mode. This delivers a steady 13.7 volts of clean power for extended service procedures such as drivability, diagnostics, or reflashing of the vehicle. This power supply mode is available in several of our wheel charger models and also our 20 amp portable model. All of our Intellimatic smart chargers are made in USA and carry up to a 5-year factory warranty. I hope you consider Associated's new line of Intellimatic chargers when you're ready to make your next charger purchase.
Okay, so what I want to highlight here, guys, is that look, you heard him talking about a deep discharge override mode. There are some batteries, and a lot of the good chargers today will not even kick on if there's less than a volt in the battery, if there's less than 1 volt in the battery, and you can't get that battery to recover. So that's where I've learned that some of these cheaper chargers are good, because you can throw that cheaper charger on there and it doesn't care. It's going to still supply power to it. It's going to get that battery back up over a volt. And once you get it back up over a volt, you can take that cheap charger off it for pretty quickly at that point and put the smart charger on it and get the smart charger to kick in and start to recover that battery. Saved a lot of batteries that way. The auto parts stores were saying were bad. So that's important. That OTC charger, the RBEST charger that I showed you prior to this, has that deep recovery built into its cycle. So you're good with that battery charger. But it's real important that you plan to spend a lot of money on a good battery charger. Get a good battery charger. We have one at the school that's a sun charger. That charger, guys, is for programming the vehicles. It has a clean power supply on it, and I will do a demo on it for you and talk to you about it. I'm very particular about when you guys use that charger. It kind of was the replacement. The school actually bought that, and that was the replacement for the Arbus charger that I took home that was my own charger. And it actually has a few more functions on it that I can use that my Arbus charger from OTC did not have. So we'll cover that and the uses of it. And you've got to be very wise with that charger because you could damage the charger. And that charger is a very expensive charger for the school. It was like 800, 900 bucks. So we want to make sure we treat that equipment properly. We use it properly. We use some of the equipment, other equipment that's out there appropriately as needed based on the needs of whatever we're doing. So it's always best to ask. I know you guys are learning. Please don't just jump in because it could be expensive if you're not 100% certain of what you're doing, okay? All right, so moving on to here. Battery charging, step 3. Set the charging rate. Initial charge rate should be about 35 amps for 30 seconds. That's just to get that battery back up over the hump. Fast charging can increase the temperature and warp the plates in the battery. The lead plates that are in the battery, you'll see in one of the other videos I do here that there are those lead plates. When you come into lab too, guys, and you come into lab, I'll have these parts laid out. Like when we talk about alternators and starters, I'll put these parts out on the table for you so that you can look at them and physically touch them. I want you to be able to touch the parts and feel them, but you need to be able to do that when you come in to the lab. So pay attention to what the parts are in these lectures and stuff, okay? Even though they're photos now, you'll get to touch them when you come into campus. So pay attention to that. But I'll put out a battery that the case is cut out around so you can see down inside the bottom storage plates for the debris. You can see the lead plates, how thin they are. Again, electron movement creates heat, right? So we want to reduce that heat as much as possible. So the slower you can charge the battery, a 2 amp or a 6 amp charge rate is better for the battery, much better for the battery than a 30 or 40 or 80 amp or 200 amp charge. That's really, really, really hard on the batteries, and you're taking a chance of burning down that battery. And when I say burning down the battery, causing the battery to fail, okay? So just be careful. Keep the amperage rate as low as possible when charging a battery. Takes longer, yes, takes a lot longer, but a lot better on the battery, okay? All right, jump starting. To jumpstart other batteries, obviously, we need a good set of good quality jumper cables. The spark could cause explosions of gases around the battery, so you want to be careful around that and be careful about causing problems. You know that from Intro Auto. You've been through this. You know the rules when it comes to jump starting a battery. The dead car, the car that is dead, that you are jump starting, you never put the jumper cable, the negative cable, on the battery post with the positive on there, right? You put the negative off to the engine somewhere or to the body of the car somewhere so that you do not get a spark near the battery. Getting sparks near the battery causes explosions, and that's not good, okay? Many newer vehicles have special ground posts. I know, like if you look at my BMW, even not my newer ones, even the old BMWs, guys, all the way back into the 90s and beyond that, back into the 60s, BMW always had a separate grounding spot to hook up for jump starting. Okay, look for those things, be aware of them, know what they are. Okay, if the owner's manual's in the glove box of the car, maybe check in there just to be sure. Okay, battery electrical test drain. So proceed to the battery electrical drain test in this case. A DMM set to milliamperes, right? Step 1, turn off the lights and the accessories and the ignition. Now this is called parasitic drain. We're going to talk more about parasitic drain. I have some videos that you have, and you have a separate module in Canvas about parasitic drain. You need to pay attention to that. You're going to be expected to do a parasitic draw test. So the video on the Power Probe 4, the hook, or not the 4, but the Power Probe hook, you'll use the hook to do a parasitic drain. You'll also use your voltmeter to do a parasitic, or not your voltmeter, your digital multimeter, and the amp meter in your digital multimeter to do a parasitic drain test, okay? So you're going to have a lab sheet on that. You're going to have to do that. I expect to see you do it right. So check all the vehicle doors to be certain that the courtesy lights are off. So one of the ways that if you need to leave the door open, to turn off the lights is to take a screwdriver and close the latch in the door. But man, you if you do that, guys, you have to make certain that you have some way to ensure you don't close that door until you reopen that latch. Otherwise, you'll bounce the door right off the locking peg inside the door. I've literally seen guys damage latches and doors, and today's latches are computer modules sometimes, guys. So it can become very expensive if you try to slam that door and you flip the latch up to turn off the interior lights in the door. So you need to be very careful and find some process, whether it be put a rubber cone right in the door jamb or something that won't allow that door to close and allow that latch to hit its latching point on the B pillar of the car. Okay, because if it does, you could bend the B pillar, you could damage the latch in the door. It just becomes problems after problem for you. So you've got to find a way, if you're going to do that, to make sure you and or somebody else that doesn't know you did that doesn't come by and try to slam that door on you and damage the vehicle. Okay, so but you need to make sure all the lights are off inside, make sure that everything's out. Disconnect the negative battery cable and install the parasitic load tool, or install your multimeter. The bad thing about disconnecting the battery, though, in this process right here that they're talking about, when you do this, what you end up doing is you end up totally disconnecting the power from the vehicle, and losing and potentially resetting the problem. If it's a module or something that's causing the parasitic drain, you could potentially end up causing yourself a problem and never find that parasitic drain, because the module resets from the time you disconnect the battery cable and disengage all the power from the vehicle to the time you hook up the tool in place in line, because amps are measured in series, right? That means you have to cut the circuit open, hook up the amp meter in the circuit. By the time you've done that, that module might have completely powered down and reset and corrected the problem temporarily for a week or two, and you never found the problem. You caused that failure in diagnostics on yourself by doing that. So I'm going to try to show you some tricks in lab on ways to not do that and to help you through that, okay? But you have to hook up these tools. You have to run these drains. You have to do a drain test. There are specs. Every manufacturer has different specs. General rule of thumb is nothing more than 50 milliamps of current draw on a parasitic drain. Parasitic drain 50 milliamps is pretty high. Some of the cars today, some of the manufacturers are speccing out 25 milliamps, which, guys, that's a super small amount of current being drawn down. And some modules don't shut down for an hour. Some modules don't even shut down for a half hour. So some modules on a car with a lot of modules on it, for example, like a Mercedes or a BMW that has 100 modules on the car, you might not get that car to completely shut down for 2 to 3 hours. So if you're trying to do a car like that in lab, you might not get that car to shut down the entire lab from parasitic drain and be able to formally check the parasitic draw on that. That's where the Power Probe hook comes in. You'll see that in the video. They talk about that and address that. So there's a lot of tools out there that can address that and help you with it. So let's move on to the next slide. Battery electrical drain test, step 4. Start the engine and test drive the vehicle. Turn off all the lights and accessories. Turn the engine and accessories off. Let it all sit. Okay. Step 6, connect the amp meter. We talked about that. We connect the amp meter to it. Step 7, open the switch on the load tool. There is a tool that you can see on the console lab engine that's inside of AT1 lab, Automotive Technology 1 lab. There's a console lab that's in the back corner by the filing cabinet on the north west end of the shop that has a parasitic load testing tool adapter on it. And that parasitic load adapter is a special tool that you put on in the place of the battery terminal, and then you turn a little nut and it disconnects the battery. But what you do is you put your meter across that and then turn the nut and disconnect it, and then you force everything through your meter. And it's a great way to ensure that you don't disconnect the modules and all that stuff from power during the process of doing a parasitic drain, okay? So many battery-related faults are due to poor electrical connections at the battery, at the grounding points where the ground cables connect to the car. contact to that stuff. So keep in mind that clean battery terminals, clean grounding connections, all of that stuff are important, okay? To jumpstart other vehicles with dead batteries, connect good quality copper jumper cables. Don't buy little cheapo, skinny cables. I will tell you that they have these little lithium booster packs that are kind of like batteries that you see everybody carrying to charge their cell phone because they have USB ports on them. But they also come with the little leads to hook up and charge a battery. Those work pretty good. I use them. I carried one around for a while. It did the job. It did a great job until I left it in the trunk of my car during the summer, and it swelled the battery up and bulged it out and broke it. Those lithium batteries, when I saw what it was doing, it kind of scared me that, hey, I could have burned my car down, and if it was in my house, in my garage, I could have burned my house down, all because the battery was swelling in the heat. So the lithium battery packs that you carry to charge your phone, that are roughly the size of this hard drive right here, I would say are not probably are not a good source of something to leave in the car in Bakersfield, where temperatures often exceed 80 degrees, 75 degrees, and in the trunk of a car you're looking at 120, 130 degrees. So that's not good, okay? That's all we have for batteries on this lecture. I'm going to have other things posted, and those are going to be lab demos, actually in the lab doing things for you to see. So when you come to lab, please be prepared to look at the components that are laid out for you. Please be prepared to get to work in the lab as soon as you walk in the door. And just so you know, if this is the first 2 weeks of class that you are watching this, your labs are not going to be related to this for the first 2 weeks. You're going to be on your electrical boards and circuit construction. So look forward to seeing you guys. I always say it. See you on the next video. If I don't see you on the next video, more importantly, and the most important thing is I hope to see you in lab on campus doing this stuff and getting your hands dirty and experiencing these opportunities to learn and grow through the kinesthetic component of hands-on. Thank you, and we'll talk to you guys later.